I'm going to move in now to example number 5. Example number 5 is about finding the domain. And finding the domain can get a tad bit tricky. And so I'm going to spend quite a bit of time on this section here. So this video will probably be quite lengthy. Probably have to break it up into 2 parts so the file doesn't get too big. But so get ready to take awesome notes, pause it at times to think about it, and to not move on unless you're understanding the concept, like replay the video and come in with prepared questions. Okay. So what we want to do is that we want to find the domain of each of these functions, and we start off with a rather easy one. And we learned in the beginning of this section that the domain means all of your x values, right? So all of your x values are your domain. So what we do is we do this. We go and say the domain is, and then we go and use these little squiggly brackets, which means that it's a set. It's a set of numbers. That's what these squiggly brackets are. So we put -3, -1, 0, 2, and 4. And that's the domain. That's all it is, right? Because that's what the domain means, is all of the x numbers. Now, for the rest of these, for part B through E, it's not going to be maybe as apparent. So what I want to do is this. Anytime that you want to try to find the domain, and now you're given some kind of an equation, okay, if you're trying to find the domain, okay, if you're trying to find the domain, all you need to do is ask yourself this one question, okay? And this is going to help you out tremendously. If you can understand what I'm about to teach you right now, finding the domain of any function is going to be much more simpler now, okay? So here's the question that you have to keep in mind when it says to find the domain, okay? And that is, what x values make the function undefined? Okay, so what functions make, or what x values make the function undefined? Meaning that it's not possible, such as like dividing by 0, right? Like we can't divide by 0. Or, I mean, we'll see other cases like, or how about logarithms, right? You can't take a log of a negative number. So if you're given any kind of a function where it says, such as like, b right now that we're going to do, we want to know what x values do you input, and then it says error. Okay, so let's go ahead and do our first one right here now. Okay, like our first one with the graph. Okay, so we have our function g of x equals -3x squared plus 4x plus 5. And let's read the question again. So what values of x do I input here, or can I input, which makes the function undefined, meaning that if I put it in, the calculator would say error. Can you think of an x value? Like negative values, positive values, 0, decimals? The answer are there are no values. Every single x value you plug in here is going to work. So if every x value works, we say this. We say the domain is all real numbers. Okay, and this is the symbol for all real numbers. And all real numbers means it's the entire x-axis. There is no value that's excluded. Okay, another way of writing this is you can say from negative infinity to positive infinity. That's another way of writing this. These are the two exact same thing. Another way that you can write this is you can say x is in between negative infinity and positive infinity. All three of these are the exact same thing. So this one, the second one, and the third one, they're the exact same answer. They represent the same information. You need to be familiar with both. If you write either one on the exam, they're both fine. But knowing all three is going to help you in your math career, especially if it's on a test and you're not familiar with one, you won't know what it means. Okay, so this whole thing is going to be all real numbers. Now let's graph this, because this is why I have my graphing calculator over here on the right. Let's graph this so we can actually verify, so that could actually make sense to you why that is the case there. I'm going to go and graph this. Negative 3x squared plus 4x plus 5. Okay, so I'm going to go ahead and graph it. And there it is. And I'm in a standard window. So if yours not like this, you can go to zoom and then press the 6. And it's going to give you a 10 left, 10 right, 10 up, and 10 down. So let's make sense of this. If the domain is all real numbers, then that means that this graph, it uses all the x-axis on the left to plot all these points, right? It used -1, maybe that's like -1, -1, -2, negative something, -3, negative something, right? So it's just going to keep going and going for the left. And then over here, it used +1, that point, +2, 3, this one, 4, and then down here, it's going to keep going forever to the right, and it's going to keep going forever to the left. So that's why the domain is all real numbers, because it uses the entire x-axis that goes to the left, and it uses the entire x-axis that goes to the right. Okay, let's make sense now of this next one, h of x equals 1 over x plus 5. Okay, again, let's ask ourselves the question, what values of x make the function undefined? Undefined, meaning it's not possible to actually get a value if you plug in some x value. Well, let's think about this for this function that I'm having you find the domain of. 1 over x plus 5. Let's see. We have a fraction. And I know there's one particular number that can't be in the denominator. No? And what number is that? 0, right? No, okay. X could be 0, but what number will make the denominator 0? That's the question. So what we do is that we take the denominator, set equal to 0, and solve for x. So we get -5, right? So since that's -5, our question now is, what values make the denominator 0? -5. So you can simply just say this. The domain is all real numbers except where x can't be -5. It can't be -5 because if you plug in -5, you get 0 in the denominator. And that's it. This is the answer right here. Or you can write it like this. Here's another cool notation. You do a squiggly bracket. You say x. You say all x values such that, okay, that's what this means, such that x cannot be equal to -5. Okay, so you could have said that. Or one more way, this is another cool one. You could kind of use what we did up here. Say you go from -infinity to -5 parenthesis. Because if you use a bracket, like if I said 5 with a bracket, bracket means 5 is included. And I can't include 5 in here because there also would be 0 in the denominator. So we put parenthesis, do the big U for mean union, and then it starts back up at -5, and then infinity. Okay, so watch. This may make a little more sense if you graph it. Okay, so let's go ahead and graph this guy here to see if it'll make a little more sense. Make sure you put the denominator in parentheses. And see if this makes sense here. See, this is the number 5 right here. And we're going to learn a lot more about this coming up here. But this is what we call an asymptote, meaning it's a line that the graph never touches. It gets super close to 5, but it never hits it. Okay, 4.99999, but it's never going to hit it. So this is why that the graph goes forever to the right. It goes forever to the left, but there's one point that you can't use on the x-axis, and that is 5, or I'm sorry, -5, and so that's why that the domain is all real numbers except where x is -5. I'm going to stop the video here, and I'm going to do a part 2 so my file doesn't get too big there.